In this lesson, we're going to learn how to read the standard normal probability tables. And so we had learned in the last lesson that we need to convert our values to a z-value. And at z, on our z-chart, our mu is 0, so our middle point here is always 0. And our standard deviation is 1. So 1 standard deviation is 1, 2 standard deviations is 2, 3 standard deviations is 3. So when we look at the normal curve, once it's been transformed, and since 0 is the middle point, this value, this point here, would be equal to a plus 2. 0 is the middle point on this graph, which it is. This point is a minus 2. When we look at the area under this tail that's shaded from the positive 2, it equals this area shaded from the negative 2. So our curve is symmetrical. And that's true if that would be a plus 1 and a minus 1. If it would be a plus 3 and a minus 3, that is true. And the whole area under the curve equals 1. So the whole area equals 1. The z-table reads from the left. So this would be the correct way that it reads. So when you get your z-value, you have the area under the curve going to the left. So going that way. So if you wanted to know the area of this part of your curve, and you had this value, you could do 1 minus this value and you would have this area to the right. But your z reads to the left. Okay, so let's look at, if you have your normal table from either the back of the book or from the, what I handed out in class, you would see it's two-sided. There's the negative side, which reads the z-values from negative 0 to the left, and then the other side reads the z-values from 0 to the positive. So the z, as I stated prior, the area under the curve is reading cumulative from that direction. So this z-value reads cumulative to that point. This z-value, just as that area is shaded, reads cumulative to that point. And I highlighted these as this is the negative side and this is the positive side. So how you read these charts is the first thing you would do when you have a problem is you're going to calculate a z-value. And you're going to have an x, a mu, and a sigma. You may have a variance of what you have to take the square root of to get your standard deviation, but you will calculate your z-value. How you read this chart is you have z, which is the beginning numbers for your z-value in column 1. And on the negative side, it goes from a negative 0.0 to a negative 3.4. On the positive side, it goes from a 0.0 to a positive 3.4. Any z-value less than a negative 3.4 has a 0 probability because this is approaching 0. So that's out here at the tail. As that tail gets closer and closer, that approaches 0. On a positive 3.4, anything greater than a 3.4 is approaching 1. Because remember, as it's going out to this tail, it's reading this way. So it gets closer and closer to the line, then that is 100%. And remember, when we talked about our empirical rule, we said that 99.7% of all your data is 3 standard deviations. So let's take a look again. Then let's start at the beginning here with the z-table. So we have a negative 3.40. So this value for negative 3.40 is 0.003. For a negative 3.41, so this value, this point would represent negative 3.41. This point would represent negative 3.22. This is your hundredths decimal of your z-value. So over here for your z-value, we'd have a 0.21 is this value. So it's your z equal 0.21. So this is your hundredths. Down here is 0.29. That's your z value. That's the z value it represents. These numbers are probabilities. These, negative 3.40, negative 3.41, negative 3.42, they are z values that you calculate. And once you have your z value, you can then locate your probability to the left of the z. If you need to the right of the z, you take 1 minus. So to the left of the z is the probability. This lines up with less than or equal to. Z is less than or equal to. If the probability z is greater than or equal to, then you go to the right. So it's 1 minus your probability. And we'll do a couple examples, but that's really important. If you ask for what's the probability that's greater than this, you need to do 1 minus. And remember, for exact, for continuous, you cannot, it's infinite. You can't get an exact. Cannot calculate, 0. 0 probability for exact. Don't forget that. There's an infinite number of possibilities, and the probability of having an exact number of a continuous distribution is 0. Okay, let's look at this problem. The ACI, which is the American Concrete Institute's definition of cold weather concreting, as stated in ACI 306, is a period when for more than 3 successive days the average daily temperature drops below 40 degrees Fahrenheit and stays below 50 degrees for more than 1/2 of any 24-hour period. In the construction area in Minnesota, we are interested to see if the daily average is below 50 degrees or not. It is established that the temperature is normally distributed, so it is normally distributed with a mean of 50 and a variance of 10. What is the value for the probability that x is less than or equal to 50? So we have to convert to z. So we're going to do z. Z is equal to x minus mu over the standard deviation. So our x value that we're interested in here is 50. So we put our x is 50. Our average is 50. So we're going to subtract 50 from 50. And then we're going to divide by our standard deviation. So this is an important step right here, is we have variance. We know that standard deviation is the square root of variance. So when we calculate this, there's a 0 in the numerator, so that's all we need to know. And this is 0. That doesn't mean the probability is 0. That means our z value is 0. So we go over to our z table, and we look at 0.00, because there's no tenths or hundredths place. And it says the probability is 0.50. So our answer here would be 0.50. Now, this is less than or equal to, so that number is a good number because we're reading from the left. If that would say greater than or equal to, we would read to the right and we would have to do 1 minus. Now in the case of 0.50, it's going to be 0.50. But in this case, we go to the z table. It's less than or equal to, so we read the z value. And our answer is a probability of 0.50 or a 50% chance. Let's look at this example. Consider we want to measure the chloride concentration on the surface of a concrete structure to see if it is compliance with our design assumptions. It is assumed that the mean surface chloride concentration is 0.3 and the standard deviation of the chloride concentration is equal to 0.04. What is the probability that the surface chloride concentration is greater than 0.29 and no more than 0.31? So let's take a look at what we have and walk through how we would solve this problem. So we know that our mean, so our mu, is equal to 0.3 and our standard deviation is equal to 0.04. And we're looking for what's the probability that x is between 0.29 and 0.31. So when we're looking, what I always do is try to draw a graph to say what am I looking for, so I know how to read my table. So I'm going to be looking for 2 z points. We want z1 and z2. And they're going to be somewhere on this graph. And we'll find out where they are in a few minutes. But we're looking for that probability that they're between these 2 points. And because these read to the left, if we subtract the small one from the big one, so if z2 minus z1, that's going to give us our probability of this gap, this area between the two. So let's do that. We'll find our z value is equal to x minus mu over sigma. So we'll do 0.29 minus 0.3 over sigma, which is 0.04. So this is a negative 0.01 over a negative, or over a 0.04. So this is a negative 0.25. So let's do our second point. So we have 0.31 minus 0.30 over 0.04. So this is going to equal 0.01 over 0.04. So this is equal to a positive 0.25. So we go to our z table and we look up our probabilities for a negative. So z equal negative 0.25. What's that probability? And so when we look at that probability, we see 0.4013. That's the probability. So that's that probability. Then we look at z equal 0.25. What's that probability? And that's 0.5987. So if we come back to our graph, and I'll just 013 is that probability that way, and 0.5937 is that probability from that point. So the difference between those two is this. So we'd have 5987. 0.5987 minus 0.4013 is a 0.1976 probability of that x is between 0.29 and 0.31.